Welcome. In this video lecture, I am going to talk about one of the multi-criteria decision-making technique, which is TOPSIS. So we will discuss what is the theory behind it, which means we will talk about how we can manually calculate this based on the TOPSIS, the best alternative. Okay, given we have the criterion weights. Okay, as well as we will also discuss the topses using R as well. Okay, so let's first of all discuss what is the topses is. So basically topses is going to select the best alternative among the multiple alternatives based on the idea that it is going to be give us the best alternative if it is having the shortest distance from the positive ideal solution and if it is having the longest distance from the negative ideal solution. So what we are going to do is we are going to calculate the ideal solutions in the best perspective or a positive ideal solution way and the negative ideal solution, and then we are going to calculate the distances. Okay, so as the definition is going saying that if you have the largest distance from the negative ideal solution, that solution is going to be the best solution, or you can say the best alternative, or from the positive ideal solution, the shortest distance is going to be the best solution with respect to the topses. So usually, in order to applying the TOPSIS, we need to give the weights to the criterias that based on what criterias we are going to select the alternatives. So in order to give the weights to these those criterias which we have selected, so for that we can use AHP technique, analytical hierarchy process technique, or either you can use best worst method as well. Okay, but in this lecture, we are mainly talking about the topses. Okay, so in order to finding or the best alternative with respect to the topses, these are the 7 steps which we are doing while we are calculating with the help of topses which alternative is the best one. So the first step is we are going to calculate the weight of the criteria using either AHB. You can use either you can use best worst method. Okay, so once we have done the criteria weight using one of the method, then we are going to give the score of every alternative. Okay, you can use the scale from 1 to 10, which is very low to very high, against the every criteria. Okay, so once we have done these first two steps, then we can start the calculation in order to get the best alternative with respect to the topses. So basically the topses, for that we are going to find out the normalized matrix, we are going to find out the weighted normalized matrix, and then we are going to find out the best first value. Okay, and then we are going to find out the negative ideal solution as well as the positive ideal solution, and then based on that, we are going to calculate the performance score, and based on that performance score, we are going to ranking it. So now let's discuss these all steps in an Excel. Basically, in an Excel, I'm going to tell how we can manually calculate the calculation of the topses. So the first of all, the problem is that I would like to pick the best university. So I have these 5 options. One is LAMS, PU, UMT, UCP, and University of Lahore. Okay, and these based on these four criterias, I am going to pick the best university. So the criteria is the cost, exposure, placement, and distance. Okay, so obviously lesser the fee of the university. Okay, so the better the alternative would be for me. Smaller the distance or lesser the distance from my home. Okay, better the university is. Larger the exposure. Okay, larger the job placement, the better the university is. So that means few criterias are the negative criterias for me. So the negative mean smaller the better. A few criterias are the benefit criterias, which mean larger the better. Okay, so for every criterias we have already calculated the weights using by applying AHP or the best first method, because that is the input for the TOPSIS. Okay, so in order to apply the TOPSIS, we already must have this data set. Okay, so these values, how we are going to fill, we are going to take the input from the expert, okay, on the scale of 1 to 10, that rate the LUMS university with respect to cost on 1 to 10, where you are ranking it, okay, based on how expensive it is or how low the cost is. Same is the case PU, UMT, and so on. Okay, the next one is the exposure. Same is the case. We are asking the expert that it should be rating the every university against this exposure. Same is the case placement. Same is the case the distance. Okay, so that means the higher the value is, which is indicating the very high uh, value, and whereas smaller is indicating towards the very low ranking, okay, rating from the expert. Once again, these ratings are from one expert. So if you are using the data from the multiple experts, let's say we are using five experts, so obviously we are going to take these ranking from different five experts, and we are going to use the average values over here. Like for example, the first expert says 9, the second expert says 10, the third expert says 8. So we are going to take the average of all these three, and we are going to place over here. Same is the case over here, same is the case over here. So once we have the weight against every criteria, and we have the alternative, and we have got the rating from the experts, so the next step is, what we are going to do is we are going to find the normalized matrix. So in order to find out the normalized matrix, we are going to use this particular formula. What it is saying that against these every criterias, okay, we are going to take the square of this number, okay, square of this number, square of this number, and then we are going to sum this up. Okay, the one way is we are should take the square of this value, this value, this value, this value, this value, and then sum it up. Or either we can apply the formula in Excel, which is sum SQ, which is sum square. Okay, so what it is going to do is it is going to take the square of every individual value, and then it is summing this up. So, okay, so we will get the first value, which is sum of square, and then we can drag and drop. So it is going to give us the sum of square of the second column, third one, and the fourth one. Okay, once we have taken this sum of square, now we are going to use this one in order to calculate the normalized matrix. So what is the normalized matrix? That is basically saying 9 divided by square root of this sum of square. Okay. So what we are doing is 9 divided by square root of sum of 271. Okay. In this particular case. So I'm using the dollar sign to make it freeze with respect to row wise. Okay, and then once we have applied, we can simply drag towards up to the distance, and then as well as the entire matrix. Okay, so now you can see that if I'm clicking over here, it should be 10 divided by 319. Okay, so this is going to be 10 divided by 319. Okay, so based on that, we have calculated this normalized matrix. Once we have calculated the normalized matrix, now we are going to calculate the weighted normalized matrix. So the second step is, so what is the weighted normalized matrix? These are the Yij values. Okay. So now we are going to multiply it this with respect to these weights. Okay. So how we are going to do is, that is basically zero point 0.2 multiplied by 0.55. Okay, similarly, zero point 0.3 multiplied by 0.50, 0.4 multiplied by this, similarly, zero point 0.2 multiplied by 0.61. So this is how we are calculating the weights. Okay, weighted normalized matrix. So we can drag and drop, right? So based on that, we have calculated the weighted normalized matrix, right? So once we have calculated the weighted normalized matrix, now the next step is we need to calculate the best and worst value against every criteria. So the idea behind it against the best and the worst value against the criterias is, as I mentioned earlier, few criterias are the benefit criteria, few are the cost criteria. So benefit criteria means maximum value is the better value for us, whereas the cost criteria is smaller the value is the better for us. So in this case, obviously that particular university which is having the lesser cost is better for us, okay, whereas the maximum cost is the worst for us, or you can say the cost criteria. So that's why in a worst and best, so in a worst what I am saying is we are applying the maximum value from this weighted normalized matrix. So that is I am saying, so in which against the which alternative we are going to bear the maximum cost, right? Similarly, the exposure, so the worst is going to be the minimum exposure, whereas the placement it is also a positive criteria or a benefit criteria. So the minimum is the worst one, whereas in that distance it should be the maximum distance is the worst one. So that's why we are considering the maximum one. Okay, so same is the case in a best way. The cost is, so the smaller is the best one. So that's why we are using the minimum from these weighted normalized matrix. Okay, exposure in against exposure. So the maximum is the best one. Placement maximum is the best one. And a distance is the minimum one is the best one. Okay. So once we have calculated this best and worst, okay, as this literature is also saying regarding this one, so the maximum Vij means that mean we are considering them as a best alternative or the best value. So that is called as a benefit criteria. Okay, whereas in a cost criteria, we are going to use the minimum value. Okay. Now, using these values, we are going to calculate the negative ideal solution, okay, as the definition of the TOPS is saying, as well as we are going to calculate the positive ideal solution, because based on these, we are going to find out the best alternative. So, in order to find out the negative ideal solution, what we are going to do is we are going to calculate the Euclidean distance. So, the Euclidean distance from the Vij values, so that is these values, okay, from the distance from the negative ideal solution, okay, which means the best or the worst solution. So the negative ideal solution is basically from the distance from every from the worst solution of the every Vij value. So that is this particular value, which is 0.109, that is a weighted normalized matrix value, okay, and then we are going to subtract it 0.121, okay, that is the worst, okay, value, and then we are taking the square, okay. So similarly, we are going to take 0.15, which is against the exposure, and the worst value is 0.084, 0.21, that is against the second criteria, third criteria placement, and 0.17. Okay, and we are taking the square, and then at the end we are going to take the square root. Okay, so once we have applied over here, then what we are going to do is we can drag and drop. Then, in order to calculate the positive solution, what we are going to do is again against the every criteria. This is and as well as the alternative, we are going to apply based on this best value. So that means 0.190 minus 0.049, and then we are going to take the square. Okay, plus then 0.155 minus 0.168, and then we are going to take the square, then 0.211 minus 0.234, and we are going to take the square, and then sum 0.063, and then this one take square and sum. And then at the end we are obviously going to take the square root. Okay, so once we have calculated this positive ideal solution, so we can drag and drop this value, okay, apply this formula, and then what we are going to do is we are going to getting these values. So once we have calculated the negative ideal solution and the positive ideal solution, now we are going to calculate the performance score. So how we can calculate the performance score? So the performance score formula is the negative ideal solution divided by the sum of the negative and the positive ideal solution. So which means this is 0.116 divided by the sum of these two. Okay. So we are going to get this performance score, right? So once we have applied on the first one, we can drag and drop. And then in order to rank it, so we are saying the ranking of these values from these metrics based on the highest score. Okay, so once we have applied this rank, now we are getting that because we are calculating this performance score from the negative ideal solution divided by the sum. So that means the higher the performance score, the better the alternative is. So in this case, the Punjab University is the number one, LAMS is two, and UMT is three, and so on. Okay. Now let me apply this TOPSIS method using R. How we can do that? Okay. So if we come to R, we need a library called TOPSIS. So first of all, install this TOPSIS library, okay, and call it. And then the first thing is I am giving the input to the R. Okay, so that means I am creating a data frame against this one. Okay, this is the data frame which I am creating. So I'm saying data frame. Then the first column is the university, cost, exposure, placement, and distance. So once we have calculated this, created this data frame, I am storing this data frame in a variable called data. And then the next thing is because for the TOPSIS, we are going to do certain calculations. For that, we only need these criterias. Okay, there is no need of the university. So that's why what I am going to do is I am going to remove this university from this data frame and convert these criterion values into the matrix form. So how we can do that? So first of all, I am saying data, that is the variable in which we have the data frame. Okay, then we are going to use this command bracket comma minus one. It is going to remove the first column. Okay, and then we are saying as dot matrix means convert this data into the matrix form. And then after converting it, I am storing into the variable decision underscore matrix. Okay, then I am going to assign the weight which we have already calculated. So that means these weights which we are going to calculate through AHP or the Westworth method. And then we need to tell the criteria. Okay, so the criteria means the criteria which we were using. The first criteria was cost. Okay, so is it a negative criteria or a positive criteria? So we are going to place it as a negative criteria because the smaller the better. Whereas the exposure and the placement was the positive criteria or the benefit criteria, so larger the better. Whereas the last one, distance, is also the smaller criteria. Okay, so once we have this decision matrix, we have this weight as well as the criteria. Now we can apply the TOPSIS method. The function is TOPSIS, and then we are giving the decision matrix, weight, and the criteria, and we are storing into a variable called TOPSIS result. Okay, if I am writing down the TOPSIS result, so I would be able to get those ranks which we have founded over here. Okay, no, I would also like because in the output it is not showing which university, which alternative. Okay, so in order to write down these alternative also in the output, what I am saying is I'm using the combined column combined formula. Okay, and then I am saying data in which we were having this data frame. From the data, I am calling a variable which is the university, and then I am saying combine it with the result of these TOPSIS results. Okay, and I'm storing into the final result variable and printing it. Now you can see that the lumps, PU, and so on. So the PU, the value is 0.6199. So this is 0.62, or if I am going to increase it, you can see that 0.6199. Okay, so similarly, the LAMS is 0.5806. So this is 0.5806. So same results we are getting. So that means are the best alternative against those four criterions are the Punjab University. So I hope you got the idea. What is the idea behind the TOPSIS, how we can calculate manually, okay, as well as how we can calculate it using the R language. So thank you so much. See you in the next video.